Hey guys, this is a video derivative of exponential functions and biggest basic chain rule. So start off by looking at e to the x, which is the exponential function. So if you have e to the x, then if y equals e to the x, then what is the derivative of e to the x? So I can go ahead and tell you that the derivative of this is e to the x. This is the only function that has its own. That's, I guess, a special case. So what this means is that if you were to graph this function, which is, let me graph it here. So the graph of the function looks something like this, exponentially increasing. This is 1, I guess. And so what it's saying is that at any point in this curve right here, the value of the slope, so slope, anywhere on the slope, and the function are the same at every single point. So at every single point, the function, e of x, is the same as it is in the slope. So if I were to take, so point from here to here, has the same, I guess you can say the slope and the functions are the same whether it's here or here. Okay, so this is the only function that has this interesting property. And yeah, so let's look at an example. So if you had e, so if f of x equals, let's say 4 e to the x, then f prime will be 4 e to the x. It's its own derivative. Okay, so now since you have somewhat of an idea of what that is, let's go to the chain rule. So the chain rule is, there's a rule for it, and it goes something like this. So if cx equals f of g of x, then what is c prime of x? This is the chain rule. And you have, so it's something like this. So it's f prime, and you leave the inside alone. And the chain rule states that you do the derivative of the inside now. And that goes something like this. So you pop out whatever it's here to here. So what you first do is you would do this derivative over here. So the derivative of f. Then keep the inside the same as the original function. Then the derivative of the inside, which is g prime, and the derivative, oops, forgot to put inside, and the derivative of outside. Okay. So let's do an example of this. So an example of this can I guess we can do this one right here. Y equals cosine COX x to the 2. So let's follow the rule. So this is the f, and this is gx. So as you can see, the rule says over here, f. So for y prime, f, we need the derivative of f first. So the derivative of cosine, which is f, is negative sine. And we keep x2 the same because this is what g of x2 is gx right there. So because of that, we keep this the same. We keep x2 square over here the same. However, the chain rule also states that you pop out whatever is inside of over here. So it's going to look something like this. So the derivative of x squared is simply 2x. So there you go. That's the chain rule. And I guess we can do another problem, but let's do one of my favorite problems, which was my favorite example, and that looks something like this. So that's over here. We did this in, I think this was an example from our exam, but okay. So this is the way this is done. So basically it puts the chain rule, combines the chain rule with the exponential function, and I think it has a little bit of the logarithmic function, but yeah, you will see how that comes into play. So what you first do here is that we have to find the derivative, and that's y prime. And to find y prime, we have to find the derivative of this, and we learned that e to whatever, it will just be itself, and we'll have a little bit of chain rule action going here. And the chain rule also states that, so this is your f, and this is, so let's just do it. So I have here, so over here is just e, leave it the same, because it is. And then you don't touch the 2x, you leave it the way it is. However, it spits out the derivative of whatever is inside, which is just 2, and then the derivative of e to the x, we already know that it is e to the x. So that's simple enough. And we can take this further, so we have e to the 2x now, and to the divided by 2, multiplied by 2. This x disappeared because of the derivative, and we can equal this to 0. So I guess I'll do it. So we equal it to 0, and then what we have here is e to the 2x times 2 equals e to the x. So we can actually now divide both sides by this, e to the x, and e to the x divided by itself is just 1. So what we have here is e to the x times 2 equals 1. This is what we have here. And we divide the 2 to this side. So we have 2 here, 2 here. So we have is e to the x equals 1/2. Yeah, and then from here, this is, I guess, where the natural log comes into play, because we already know that natural log is the inverse of e. So in order to cancel e, we can just use ln, and ln comes into play here. So we can do ln of times e to the x, and we know that they cancel each other out from pre-calculus, I guess. And 1/2 of ln here. So whatever you do on this side, you have to do on this side. and these cancel each other out. So what you actually have is just x equals 1/2 ln. But that's just x, and now we found x, and we can use x to find y. So what the y is, the function of y. So the way you find the function of y, it's like this. So you just substitute x over here. This x is 4. This right here. So let's go back. So y equals e to x minus e to the x. So let's substitute y equals e to the 2 1/2 ln minus e to the ln of 1/2. Okay, so you can do a little manipulation with this one to cancel e, and with this one you already know that this e and this ln will cancel each other out, leaving you this 1/2 right here. So the manipulation of this one goes something like this. What you can actually do is e to the ln times 1/2 and square that. So you can do that. So do you see that? So you bring this 2 and square this over here, and now we have e and ln together where we can cancel them out. So we can cancel these out, and what we are left with, and again we cancel these one and this one out because they're inverse of each other, and leaves you with 1. And so what you have here is 1/2 square minus 1/2, and we are pretty much done here. So so now you have, so just do this and you're going to get -1 to the 4th, and that's your answer. That's what y is. So your y equals -1/4, and your x equals over here, which is 1/2 ln. So that's your answer right there. And this is not an easy problem to understand, but okay, yeah. Alright, thank you for watching.